Hello students, myself Professor Ankur and I welcome everyone for the GATE theory session on analog circuits. Today we are going to cover an important topic, timer IC 555 as a square wave generator. This is our fourth session on timer IC 555. Let's start with the session now. So before we start with the topic, we can actually recollect a diagram without the diode. So it is the same diagram which is being shown in the figure, except the diode was absent. So between pin number 4 and pin number 7, that is pin number 8 and pin number 7, there was a resistance by the name R1. Between the 7 and the 6, there will be a resistance by the name R2. 6 and 2 will be shorted and connected to a capacitor C. At output 3, that is pin number 3, we are going to measure the output. Pin number 1 and pin number 5 will be grounded. So that was actually the diagram of IC 555 as a astable multivibrator, where the capacitor was charging from 1 by 3 VCC to 2 by 3 VCC and then discharging from 2 by 3 VCC till 1 by 3 VCC, and the operation was continuing, and simultaneously at the output pin we were getting rectangular pulses. So we were getting the output as high output and low output, high output and low output, and so on. So when we talk about that astable multivibrator circuitry, there was no arrangement where we can get a concept of a square wave generator. So if we want to get a concept of a square wave generator, we put a diode across the resistor R2. So what will happen because of this? Due to this, when the capacitor will be charging, the charging path will be controlled by the resistance R1 and the capacitor C controlling the time constants. And during the discharging effect will happen only through R2. So now when I measure the on time of the pulse, it will be 0.693 R1 into C, and the off time of the pulse will be 0.693 R2 into C, because during the charging effect of the capacitor to 2 by 3 VCC, it was happening through R1, and during the discharging effect of the capacitor till 1 by 3 VCC, it was happening only through R2. So now the on time and the off time are the functions of R1 and R2. So the total time of the output pulse will be T on plus T off, which will give me 0.693 R1 plus R2 into C, and the frequency will be 1 by T. Now we can go for various duty cycle arrangement. If I want exactly 50% duty cycle, that is for a square wave or a square pulse, we will keep R1 and R2 equal so that the on time and the off time becomes equal. So the width of the pulse for on time and the width of the pulse for the off time will be same, and we get a square wave. So this is our required application of IC 555 as a square wave generator. On similar lines, we can go for other forms also in the same circuitry by just modifying the values of R1 and R2. If the value of R1 is less than R2, we will get duty cycle less than 50%. And if I just modify R1 greater than R2, we will get a duty cycle greater than 50%. So in this way, by just putting a diode in the circuitry, we get all possible variations in the duty cycle. Whereas when we compared with respect to the original astable multivibrator circuitry, the on time was normally greater than the off time. So the duty cycle was always going to be greater than the 50% value. And that's the reason to put a variation on the duty cycle and the on and the off time, we can put a diode in the circuitry. So with this arrangement, we can get various pulses of multiple duty cycles, of which one of the case will be R1 and R2 being same. You will get on time and off time equal, due to which the duty cycle will be 50% and the waveform will be called as a square wave. So this is how we use IC 555 as a square wave generator. Thank you.